Welcome to this lesson. So typically, when you study y equals mx plus c, you draw a load of straight line graphs, and the teacher might say, get you to draw ones where you vary c, and you see that, oh yeah, they're all parallel. They just go through the axis in a different place, and that kind of makes you, link the this m to the gradient, and then you might then vary the gradients for a particular value of c, and then you might see that they all go through the same points just with a different gradient, and that links the idea of c to being the y-intercept. That's not really proof in maths, and I want us to think at the start of today about how do we really know that m is the gradient. It's all right doing a few examples, but that's not convincing in maths. So I want you to pause the video and have a think, or like maybe play around with the equation to argue a case for why m is the gradient and c is the y-intercept. Okay, I think I'll talk about the y-intercept to start with. And essentially, when x equals 0, for this equation, it's going to be m times 0, and I'm going to get y equal to c. So in some sense, it just falls out the equation naturally. Like when I let x equal 0, I will get the value of c. And for me, that is convincing enough. I'm happy with that one. If we look at the first one then, this slightly tricky one, how is m the gradient? Well, one approach, which I really like, is to write down, like pick a point on the line, and let's call it x1 and y1. Then we're going to get that y1 is equal to m x1 plus c. And then I'm going to pick another point, x2, y2. This is a general point, it could be anywhere. And then when I substitute that in, I'm going to get y2 equals m x2 plus c. How does that help? What I'm going to do now is use like an idea from simultaneous equations. I'm actually going to take the bottom equation and subtract the top equation. So I'm going to subtract the left-hand sides, and I'm going to get y2 minus y1 on the left-hand side. And then when I subtract the right-hand sides, I'm going to get m x2 plus c minus m x1 plus c. I'm minusing the whole thing. That is equivalent to getting rid of the bracket and putting a minus there, because I'm going to be minusing the mx1 and then minusing the c. And what that does is it cancels out the c. So that was the whole logic behind that. And what I can then do is I've got a factor of m in both. I can factorize out the m, and I'm going to get m x2 minus x1. And therefore, I can divide through by x2 minus x1 all in one go, and I'm going to get that m is y2 minus y1 over x2 minus x1. This is just fallen out of the equation, and this actually is the definition of the gradient. It's the rise over the run. If I now, I've got my c there. Okay, if I put 2 points on it, I don't know for sure that it's going to be a straight line through at the moment. Then I'm going to do, I've got x1, y1 here. I've got x2, y2 here. You can see that this distance here is going to be x2 minus x1. And you can see that this distance here is going to be y2 minus y1. And that makes it a bit clear that it is rise divided by run. And because I've got, these are just coordinates, it's going to be a constant. I can see between 2 points, I'm going to get a constant gradient just between these 2 points. But the points were completely arbitrary. Like they could be anywhere. So actually, it must be like I can move it up here somewhere, and it must be that I get this straight line graph. So I suppose what I've tried to show you is that y equals mx plus c must be a straight line graph because of what I've said. The m is a constant, and it's always equal to this, which is rise over run. which is the gradient. So I've convinced myself of that. And then this other thing is that it will necessarily go for this c when x is 0. So that's my little argument for why m is the gradient and c is the y-intercept. Just one final thing I'm going to say, like another reason why you might see it as the gradient. You can see that if you increase x by 1, let's have a little go. I'm just going to get rid of this now. Just one final little argument. So if I had y equals mx plus c, if I increase x by 1, then I'm going to get x plus 1 plus c, and that is going to equal mx plus m plus c. And what I see is that if I increase x by 1, y will increase by m, which is another way of saying the gradient. It's to do with the gradient. If I go 1 along, I'm going to go m up. Yeah, and m is the rise over the run, or it's how many you go. Well, you go along 1, that you're going to go up the gradients. That's another way of thinking about it. So I like this little explanation as well. I hope you're happy with it as well. Today we're going to extend y equals mx plus c into the idea of parallel lines. And essentially, I'm going to give you the equation of a line. I'm going to tell you another line is parallel to it and it goes through a point, and then I'm going to ask you to work out the equation of that line. And so we're no longer going to be drawing these lines, we're going to be working algebraically. And the absolutely crucial thing to say is that parallel lines will have the same gradient. That is going to underpin today. You can see that. I'm going to have the, because they never meet, they must go along and up the same amount for every little bit. If that goes along there and up there, it's got to be the same. Same gradient, same m. So let's look at a question. We've got two lines, line A and line B, and we're told that line A has equation y equals 6x plus 7. That's this one here. Line B passes through the point 4, 26. I don't know, it's some random point here. Okay, there's no points, like no axes labeled apart from this 0. So I've just put it there. Find the equation of line B. Now, if you're feeling confident, if you've seen this before, if you just want to give it a go, then pause the video and go for it. My standard approach for this is as follows. We've got line B. Let me do that again. It looks like it's not 2 words. Line B. Okay, we can write down that it's going to be y equals 6x plus something, plus c for its value of c, because it's got the same gradient. That's where this is coming in. Already we're using it. Because I've got 6 here, I've got 6 here. Just going to write that in brackets. Now remember, x and y are varying across this line. And it so happens at one point, when x is 4, y is equal to 26. And we can substitute that in. Sub in x equals 4, y equals 26. So I'm going to get that 26 is equal to 6 times 4 plus c. And that's equal to 24. I can minus 24 from both sides. I'm going to get that c is equal to 2. And I've managed to figure out, I figured out both the gradient of the new line, because it's parallel, it's just exactly the same as the line A. But now I've also figured out my value of c. So my final answer is going to be, I don't just have y equals 6x plus c, I have y equals 6x plus 2. And I'm done. This level of working is what I would expect to see. Really powerful, and this is going to be useful for more advanced maths when I just give you 2, this is not today, but if I gave you 2 points and asked you to find the equation of the line through it, or if we're talking about perpendicular lines. So try and get your head around this. Really powerful method, working purely algebraically. We don't need the graph at any point. Just going to say one thing, like if you do struggle with this concept, you can get away without sometimes, and this is how you can do it, because you can kind of work back. We're trying to work out this point here. As long as you've got that y equals 6x plus 7, sorry, I just realised that didn't show up properly, plus 2, that should have said. Right, if you've got y equals 6x plus c, then this is our value of c here. That was meant to be a cross before c. Okay, if I've got a gradient of 6, that means I go along 1 and up 6. And it also means that if I go back 1, I'm going to go down 6. So I could I could work my way backwards to the line. I'm going to get 3, 20 as a point. Because, yeah, if I go 1 along up 6, I'd get 426. If I go back 1, down 6, that will work. And you can just keep doing that. You can go back 1 again, and we'd get 214. Go back 1 again, I'm going to get 1 and 8. I can go back 1 again, and I'd get 0 and 2. And that is another way you can do this question. My advice is stick with this, but it's a nice way of thinking about it as well, I think. Over to you. Can you have a go at these two questions using similar techniques to above? No graphs drawn this time. You can sketch one if it helps, or you can just go straight for it algebraically. Pause the video and resume, and I'll talk through it. So, first one, a line is parallel to this equation here. That means it's going to be y equals 2x plus something. Let's call it c, because that's going to be my value of the y-intercept for that line. And this is because it's got the same gradient because the lines are parallel. Now I've got a point to substitute in. Just going to make that really clear. When x equals 5, y is equal to 6. So I can substitute that in. I'm going to get 6 is equal to 2 times 5. I'm going to go straight for it and write 10 plus c. Okay, remember, I know what m is. X and y are varying, but I have a particular point. I don't know what c is. I can write an equation in terms of c that link x and y. And then I can see that c is going to equal minus 4, and therefore y is going to equal 2x minus 4. And if I substituted it back in, x equals 5, I'd see that y is equal to 6. Like, it works. It's definitely correct. So that's how we can deal with it. I don't need to draw a graph and try and figure this out. Like, I could sketch the graph. I don't know. It's just like, it just doesn't feel like it's worth it. You know, we want to be able to deal with these things algebraically. Last one. Okay, actually, this is a bit of a trick one in some sense, because it's actually easier than you think at first. I'm going to write down that y is equal to 3x plus c in exactly the same way as before. Same gradient. Immediately, I'm showing my understanding about the parallel lines. And now I can substitute in 0, 1. When x equals 0, y is equal to 1. But this time, look what happens. I'm going to get 1 is equal to 3 times 0. That's just 0. 1 is equal to c. And I get that y is equal to 3x plus 1. And actually, I didn't need to do this method here. I didn't need to substitute it in. I can see immediately that it is the value of c, because it is 0, 1. It goes here. That's, by definition, is my y-intercept. So when you get a question where you have 0 here as your x value, you get your value of c for free, essentially. If you don't spot it, you can still substitute it in, but you know, you can do it more quickly if you notice it. Okay, that is it for now. What I like to do is try some questions and master this topic. Well done.